In this tutorial, we're going to use processing to draw a single segment of a robotic arm. Right. We're going to draw a segment that's going to be pinned at the origin in the processing window, which represents this fixed point in the robotic arm. And we'll call this point A. We'll call this point B the other end of the segment. And what we'll do eventually is we'll have this segment rotating from 0 to 180 degrees. Right. We'll start then simply by drawing it statically and processing before we have it moving. Right. So let's just start with a blank processing sketch. We'll start writing, and what I'd like to do is our objective is to create something that looks like this. Right. We want to talk about processing. If you haven't used it very much or haven't used it in a while, I want to remind you that when a processing window appears, the origin, or the x equals 0, y equals 0 point, is in the upper left-hand corner. And what we want to do is we want to represent a coordinate system where we're going to use the center of the window as our origin, as our 0, 0 point. And there's different methods of doing this in processing. Processing has a translate function that actually lets you move the origin. But today we'll just go ahead and keep track of the offsets that we need to move this without using the translate function. So the first thing we'll do is let's take a look at how we would just create this drawing to break things up into these quadrants, right? This is going to be our quadrant 2. Here's our x-axis, here's our y-axis, sorry, quadrant 1, our x-axis, our y-axis, quadrant 2, 3, and 4. This is what we're used to in looking at a two-dimensional coordinate system. So let's take a look at then how we would just even draw the x-axis. Right. All right, so we'll start with this blank sketch here. All right, processing has a couple of functions, setup and draw. Setup, in the setup function, it runs once and only once at the start of your program. First thing we're going to do is to create a window that's a square window that's 600 by 600 pixels. And then in the draw loop, right, I call this a draw loop, sorry, this is a draw function. It is an infinite loop that runs over and over again. Right. If I simply want to draw a line, so we're going to draw a horizontal line in the center of the window. Right. We call the line function, right? The leftmost x coordinate is 0. The vertical center of the window then is, we're going to use height divided by 2. So this system variable comes from processing. It gets updated whenever we set the window size. So height right now is 600. This is the y component, or the height component, sorry. This is the width component here. So we'll say height divided by 2, and then the opposite side of the window, the x equals width position, and then height divided by 2. So width is set as well. Then the width of the window is 600, height 600. Right. If we run this, right, this comes up and we get this window that has a great background, but here's our line that we just drew in the center of the window. Let's maybe then sorry, not draw, let's set the background. Here. Oh, that's awfully dark. Let's make it white. All right. So now I've got the x-axis. I think I'd like to label the x-axis as well. And to do that, I'm going to call the text command. It's going to write text in the window. So what I'd like to write is x-axis. That's a string. I put that in double quotes, and then I have to say where I'd like it to write it. Well, x coordinate that I'd like it to write it is not all the way to the left, maybe width minus 40, so 40 pixels to the left edge of the window. That's kind of a guess based on the size or length of the text. And maybe height divided by 2 puts it right on the line. So a little below the line at a greater y position, maybe I'll add 10 to that. Right. Now, if I run this, we're not going to see the text because the default color of the text is white, the default fill color right now. So let's just make that text black. All right, X-axis, right? And that's a little hard to see maybe with our window, or sorry, with our line being black. So let's perhaps just change this to some shade of blue. All right, there's our X-axis there, our label. All right, let's do the same then for the Y. All right. So we're going to draw a vertical line in the center of the window. All right, so that will be at width divided by 2. There's our X, our Y. One Y will be 0. The other X will be the same for the vertical line. The Y will change. And let's make that height. And then let's go ahead and draw our label for our Y-axis. All right, here's our string that we want to display on the screen with a text command. All right, now let's say this is width divided by 2. I don't know, maybe -10 a little to the left, and let's maybe just put that at Y equals 10, and let's see what that looks like. All right, so we see Y-axis, X-axis. Right, you can play with the spacing on this. You want, you can make the text bigger by creating a font object. Right now I'm just using the default. Right, now that we've done that, let's go ahead and draw in our coordinates information. What I'd like to do is, let's write a function called draw axes. It's not going to return anything. And if all we do is take this code, which control that, right, and move that in here, and then call our function draw axes. All right, we get that. Same thing we had before, just want to make sure that didn't make any mistakes with my changes. And let's maybe then write some code that draws in the coordinate label. So void draw, sorry, I said coordinate, I meant quadrant labels. We'll just use the text command for that. So the text then we want to write is quadrant 1. All right. So this is going to be 3 times width divided by 4. Might need to left adjust it a little bit. And let's left adjust that 40 pixels. And now the Y position is going to be height divided by 4. Let's try that. And let's use some copy paste magic here. Okay, quadrant 2. All right, I want that to be on the left. Here, let's see what we've got. And I forgot to color the text, right? Because I'd set the fill color. Oh, sorry, I didn't forget to call that. I forgot to call the function to draw it. All right, that's why we're not seeing it. We don't call it. All right, quadrant 1, quadrant 2. And if we wanted to change, then the text color, if you go back to fill, we could go back to black here. All right. And now quadrant 3 will be same x position, maybe 3 times height divided by 4. And quadrant 4. All right, so I did this simply to make a point of the coordinate system we're used to seeing. We're going to consider this part of the window to be our quadrant 1. These will be positive angles. Then above the x-axis, as we rotate in a counterclockwise direction, we'll go from 0 to 90 to 180, right, to 270, back to 360 degrees. Right, let's label the origin as well. Text 0, 0. Our x and y coordinates here. All right, and there's our 0, 0 position, our origin. Or we could draw an ellipse there. But for now, then, we've labeled our system. Right. Now let's get back to the idea of that line we want to draw to represent that linkage. Right. So, segment 1 variables, right? We're going to draw the segment. We're going to have then an x, so I'm going to have an ax and an ay. So one end of this I'm going to call a, the other b, right? The other bx. And let's give a length to that segment. Maybe just make it 100 pixels. All right, so here, if we want to initialize ax and ay, so I'm going to fix ax, ay in window center. Right, so we'll just simply say ax is equal to width divided by 2. Ay is equal to height divided by 2. Right, we've got our quadrant labels. Let's just draw point A. We'll use an ellipse to do that. Let's maybe fill that ellipse with red. All right. All right, so ellipse is center mode by default, so I'm going to put the x and y coordinates that represent the center of the ellipse, so that'll be ax, ay. All right, just maybe going to give it a default radius of 10 to draw that point. And let's run this. All right, and there's our point A here in the center of the window. All right, what we'd like to do then is let's draw point B. Right, we want point B to be the other end of the linkage. So B is offset to the right in terms of the x coordinates by the length of the segment. The y coordinates will be the same. So if we set then bx, right, be equal to ax plus then the segment length, and by is simply the same as ay. When we drew point A, let's just go ahead and label it as well. And let's turn off then the origin label. And then let's draw B. And label it. So BX, BY, let's move that above that point. Let's see what we have. All right, so here's our AX, AY, our BX, BY. We want to draw a line then to link those. Right? And if we wanted to display the coordinates, then let's do that as well too. Let's write a function that void display coordinates. And let's then, in the console window, which is down here, let's use the print function. So let's print, right, AX. So there's the string. The string goes in double quotes. Now the string library here in processing in Java, we can use the addition operator, and that says append some information to it. So this will actually append the value of AX there, right? Convert the number to a string, and then let's add to that comma space AY. Let's print out then the AY coordinates, and this will all be on the same line. Right, no new line. And if I say print ln, well, now we can BX, right, that string plus BX, X plus space BY, and then have it append BY to this, and then I'll write a new line after that. And then let's call display coordinates. All right. And if we do that, we're going to see these coordinates displayed over and over again. Let's see how that's scrolling by. Well, since this is a static drawing, I'm going to hit the stop button here. And here, let's call the no loop function. So in setup, if we call no loop, that'll cause the draw loop to execute just once, right? Which is, this is a static drawing at this point, that's just fine. And we can see our AX, our AY, well, our center of the window, our window size is 600. So in the center, the width, right, is 300. Width divided by 2. Height divided by 2 is 300. And then VX then is 100 to the right. That's the segment length. And BY is at the same point. Right. So let's draw then a line in between those 2 points. And, right. So we're going to draw point B, and then let's draw a line from point A to point B, right? That represents then our segment. All right, let's maybe give the line a different color than the endpoints, so we'll see that piece that we're drawing. You can make everything all one color. I'm just trying to make it different so that you can see the different pieces. Draw a line, right? Again, we call the line function. So we're going to draw a line from AX to AY to BX to BY. And if we run that now, oh, Phil isn't right. No, sorry. Line is controlled by a stroke color. So my stroke here is green. Now, if I do that, it's going to make the stroke color. So if we run this, we're going to see the stroke color is green everywhere. Right. The stroke color ends up being green around little circles, especially then if I go ahead and let's increase the stroke weight. By default, it's 1 pixel. So let's make it 4 so we can see our line better. All right, so now we can see our line. And then I think when I draw these ellipses, I'm going to say no stroke. So there's no stroke color around them. Now when I turn this back on, we'll still get our stroke. All right, we'll get the stroke there as soon as we turn the stroke color back on here. All right, so now we've got our line. And what I'd like to do, of course, is to move this in its own function. So void, we're going to call this draw segment 1. And here's all the code that we just used to draw this, point A, point B. And then we have to call that function from within here. All right, we have our same drawing again. There are coordinates, right? And so now we have a static drawing, in this case of this line, right? Which would be at 0 degrees, right? What we're going to do, we said, here's our x-axis. As we go counterclockwise, we're going to say this goes from 0, it's going larger up to 90, right? From 90, it grows toward 180 degrees. I'm talking about degrees, or in radians, from 0 to pi. Here then in degrees we'll go from 180 to 270, or 3 pi divided by 2, right, over to 360 degrees, or 2 pi. Right, that's the way we're going to interpret our coordinate system. Right. And what we want to do then is we want to incorporate an angle. Right. Here we hard coded then bx and by, but we're going to want bx and by to start moving, and its position will be based on an angle theta 1. Right. And let's just set now theta 1. Let's initialize that to 0 degrees. That's the position of our line. And now let's calculate the b coordinates. Right? So we're going to say, let's write a function called void update coordinates. And let's pull out the b stuff from here. Right, let's put it in here. Right? And all right, before we draw things, our axis and our labels are fixed. Right? At some point before we draw our segment, we probably want to update the coordinates. Then draw the segment, then display the coordinates. If all we do is make these changes where we create the function and then call the function, right, we still get the same result, which is good. And now let's then throw in theta. Right? If we pop this up, then using trig, right, bx is simply going to be then the line segment times the length times the cosine of theta. And by's position then is the segment length times the sine of theta. Plus we need to offset it from the origin, right? Normally when we calculate this, we calculate things around the origin, the 0, 0 point, but now our origin's ax and ay. What we'll say is we'll adjust this to segment length times the cosine of theta 1. Now what I didn't say before is we're going to keep track of these units in degrees. The reason we're going to do this is eventually we're going to interface this sketch with Arduino. And we're going to transmit information from processing to Arduino in degrees, right? Because we're going to use this information to control a servo motor that needs information in degrees. What we'll do here then is, all right, this cosine function required. It assumes whatever number you pass it as radians. We're going to call this processing function named radians, pass it theta 1, which is in degrees, and it'll return the angle in radians and then pass that to cosine. And now if I say A1 or AY times segment length, right, times the sine of radians, theta 1. Now if we draw this, do we get the same result that we had before? Yes, we get the same result. Good. Right, so we add a little bit of code, we test it, we get that working. And now let's take a look at what happens, well, if we start if we start changing theta. So in this case, if I were to make theta 45 degrees, well, with processing, what we just calculated, since the angle was positive, right, let's look at this. We said, here's our results then for BX, BY. Right. The BX is still, if we pop this up, we'd expect, sorry, let me pop this back up. We're treating this as quadrant 1. X is positive, Y is positive, right? We'd expect here X to be positive and Y to be negative. Well, in order for us to rotate, we want to rotate our 0 to 180 degrees. We need then to subtract this value that it calculates for Y from AY. Right? AY then is height divided by 2. If we want to display something above that, we need to subtract out this segment length. Right? So now if we do that, notice now our Y position is less than it was before. Right? Simply because we're controlling drawing. We're controlling the visualization here, not real X and Y coordinates. Right? The X and Y coordinates in relation to our origin. Right? So that works now for 45 degrees. Let's go ahead and test it. Right? We could test it with 90. So we'll change that. Right, there's our 90. And we can display that information as well. So display coordinates, or we can also display, we're going to display angles. Maybe we'd give it a better name, but let's say theta 1 plus theta 1. All right. And let's get rid of the ln here. Let's just put this whole thing on one line. All right, and there's our theta 1, 90 degrees. All right, we want to still keep working. Let's test it all the way over to 135. That looks good. Let's try one more. Let's just try 180. And there's what we interpret as 180 degrees. Good, so now we've got a drawing, a static drawing of this then, representing our linkage in these different angular positions, right, in quadrant 1 and quadrant 2. Right. And let's make sure that work is saved. Right, so I saved that as robot arm single linkage static simulation. Right. In the next tutorial, we'll see how to make this arm move.